This video here is going to run you through transformations that can be done to circular functions. Okay, but this word circular here can be changed to logarithmic, to exponential, to quadratic, whatever you like. Okay, the same idea will apply to all the transformations problems that you do. So this should be nothing new, it's just new because we are doing it on a trig function and not a log, not an exponential, etc, etc. Okay, so we're going to dilate this y equals sine x by a factor of 2 from the x-axis. So let's put down the mapping. So dilations from x change y, so we're going to go x to y. Next transformation, dilated by a factor of 3 from y, that changes x, 3x to y. Translated 5 units in the positive direction of y, 3x to y plus 5, and negative direction of x. Okay, so the big point I like to do is to put my x dash and y dash above there. X dash is found by doing this, y dash is found by doing this. Alright, so let's write that out. X dash is found by doing 3x take 2, and y dash is found by doing 2y plus 5. Okay, so now we're going to make x the subject, so we're going to do x dash plus 2 on 3 equals x, and we're going to say that y dash take 5 on 2 is equal to y. Take a couple of steps with that, there's no harm in that. Alright, so now what we're going to do is we started with y equals sine x, and to do the transformations we're going to make this substitution. So x is going to get this value here and y is going to get this value here. Okay, so we're going to make that substitution. Y dash take 5 on 2 is equal to sine of x dash plus 2 over 3. Alright, we're going to drop the dashes now because this is a function in its own right. Okay, and what we're going to do is just transpose this to make y the subject. So I'm going to multiply both sides by 2 and add 5 to both sides. So I'm just going to say y is equal to 2 sine x plus 2 on 3 plus 5. And that's my new function, or my image of the pre-image. Alright, same deal, dilated by a factor 3 from the x-axis. So let's run the mapping. Dilations from x change y. Translated pi units, so we've done that one. Translated pi units in the negative direction of the x-axis. Done that. Dilated by a factor of 1/2 from the y in that order. So we're going to go half x take pi, comma 3y. Alright, so there's our mapping. Alright, so we'll go x dash and y dash at the top. X dash, the image, can be found by doing that. Y dash can be found by doing that. Alright, so now what we need to do is make x the subject and y the subject. So let's take a couple of steps on this. 2x dash plus pi equals x. I can do this in one step. Alright, and y dash on 3 is equal to y. We started with y equals sine x, and so what we're going to do is sub in these things here. So we've got y dash on 3 is equal to sine of 2x dash plus pi. Now we're going to drop the dashes and make it a function in its own right, and I'm going to transpose it at the same time. Y equals, I'm going to multiply both sides by 3 sine 2x plus pi. Alright, so here we're going to state a possible sequence of transformations that have been applied to this to give us this. So by recognition I can tell that this is dilation factor 2 from what's it from x, and this is going to be 1 on 3, so third from the y-axis. Okay, so by recognition I can do that, but let's punch out the transformations and see if I'm right. Woohoo. Okay, so what we're going to do is say we're going from, so I put the word from y equals sine x to y equals 2 sine 3x. Alright, so this is the original, this is the image, so I'm going to put my dashes in there. Alright, so now what I want to do is reconfigure this to look like, what am I going to get it to look like? To look like this, okay? To look like it was when I ran this step and substituted, alright? So how do I do that? Well, what I do is I'm going to go y dash on 2 equals the sine of 3x dash. Alright, so now I'm going to pair them off. I call this pairing them off. I don't know whether that's the right term or not, but that's what I think anyway when I do it. So these two pair off with each other. Now, y is y dash on 2, and x is 3x dash. Alright, so sometimes I sort of think, well, what do I do here? What am I looking for? I'm looking for the transformations. Alright, now if we look at that via mapping, what's going to happen is we have a bunch of transformations that are done to produce x dash and y dash, the image. Alright, so I basically, to find out the transformations, need to find out what x dash is, and I need to find out what y dash is. So over here, I know now that I need to make y dash the subject, and I'm going to put the result there, and I need to make x dash the subject, and I'm going to put the result there. So if I make y dash the subject here, I'm going to go y dash equals 2y, so 2y goes there, and I'm going to make x dash the subject here, which is x on 3. Alright, so now by I can see here what's happening is we're dilating, I can spell, 1/3 from y, that's this one here, so we're multiplying the x value by 1/3, and remember dilations in the x-axis, or dilations in the y-axis change the x value. And we're also going to dilate factor 2 from x, that's that one there. So again, I knew that by recognition, but this mapping or this technique will show you what the transformations actually are. Alright, so now why do we need to do that if I can do it by recognition? Because this this one here is quite difficult to see. Alright, so I really can't state this with absolute 100% certainty. I'm at probably 80%. I reckon I'd probably get this right if I tried, but we want something a bit more ironclad than that. Alright, so what I'm going to do is I'm saying I'm going from y equals the sine of x to, let's just check whether that was the original, yes it was, to this thing here, which is y equals -3 sine 2x plus pi on 4 plus 1. Now what I'm going to do is put my dashes in to indicate that this is the image. And now what I do is I need to reconfigure this so as before it appears as it would after I subbed in my y and x value to find the image. So what do? I'm going to go y dash take 1 over -3 is equal to the sine of 2x dash plus pi on 4. Alright, these are now ready to pair off. Okay, so what I'm going to do is say that y is y dash take 1 over -3, and x is, so this x pairs off with this, x is 2x dash plus pi on 4. Alright, so is that the transformations, and is that the transformations, is this dilation factor negative? You know, I don't know. What do I do? How do I read off the transformations? Well, let's actually work out what we're doing. The pre-image maps to this, something here and something here, to produce the image. So here I know I need to find out what goes here to make x dash. And it just so happens that I can make x dash the subject here, and I can make y dash the subject here. So let's do that. So I'm going to multiply both sides by -3, so I get that, and I'm going to add 1 equals y dash. So y dash is that, so I'm going to put that in, -3y plus 1. Alright, now I'm going to make x dash the subject over here, so I'm going to go x, take pi on 4, and what I'm going to do then is divide the result by 2 to get x dash. Alright, now to do that, what I'm going to do is say that this is x over 2 take away, and pi on 4 on 2 is the same as pi on 8. Alright, so these are the transformations. There's bucket loads of them. Okay, so let's read them off. So I've got a dilation factor 1/2 from y. I'm going left pi on 8, so that's those taken care of. I'm reflected, this is this negative now, I'm reflected in the x-axis. I'm dilated 3 from x, takes a lot of thinking this, and I'm going 1, I was going to write the word 1 up. Okay, so that's all my transformations that are done here. So to get from the original y equals sine of x to this thing here. Okay, so we can see a couple of them that we can definitely confirm here. The +1 is up 1. This one here, if you look at it and take out 2 as a common factor, we've got x plus pi on 8, and we know that that moves pi on 8 to the left. It's 1 on this value here to produce the dilation from y, and it's reflected in the x-axis. So we can see these transformations here by sight, but the best thing about the mapping is it will produce a guaranteed order that works. If you do it by recognition, I find that sometimes I get the order wrong. So that's a pretty difficult one there, lots going on with that one, but again it's really the same process every time. Alright, so the other configuration of a transformations problem is this one here, where we're going from this, which has been transformed already, to this, which has also been transformed. It's not going from the transformed back to the original or anything. So let's do it, and it's again a fairly hard, a fairly similar process each time you do this. So I write from y equals 4 sine 2x take 5 to the original, which is y equals sine of x take 2. Okay, so this is the original and this is the image. This is the one I'm transforming to get to this. So let's put our dashes back in. Alright, so this time neither of them are ready to pair off. Okay, so we're going to have to do some work on this one and this one to get it ready to go. Alright, so I'm going to do y plus 5 over 4 equals the sine of 2x. So I've just divided, added 5 first of all, and then divided by 4. And I'm also going to do this one, that's y dash plus 2 equals sine x dash. Alright, now they're ready to pair. Alright, so I'm going to pair this with this. Y plus 5 on 4 is equal to y dash plus 2. And I'm going to go x dash is equal to 2x. Alright, so now what I'm going to do is, do I transpose, do I make x the subject, do I make x dash the subject? What am I trying to do? So what I do is I write out my mapping. Stuff and stuff happens here to produce the image. Okay, what's that stuff? Okay, It's the stuff that's done here. So x dash here is 2x. So I put that straight in. Nothing needed, okay, on that one. So I can put that straight in. Now over here, I want to find out what was done over here to create y dash. So I need to make y dash the subject. So it's going to be y dash equals y plus 5 on 4, take 2. Alright, so that's a bit tricky there. Let's sort of reconfigure that to clean that up a little bit, because what would this be? It's a dilation factor quarter, shifting right 5 and shifting 5 on 4, and then shifting left -2, or shifting left 2 rather. And you can see even I'm trying to say it to you right now and I can't read that properly. So I'm going to rewrite y dash as y on 4 plus 5 on 4 take 2. And now I'm going to clean this up a little bit. This is 5 on 4 take away 8 on 4. Okay, so this is y dash equals y on 4 take away 8 on 4 is -3 on 4. Alright, so this is what y dash is. It's y on 4 take away 3 on 4. Alright, so now I can simply read off the transformations. This is a dilation to from y, okay, which changes the x value. Over here we've got a dilation quarter from x, and we're going left 3 on 4. Okay, so yeah, again, I think that's really hard to see that from that. I mean, that just doesn't work for me by sight. So I really need the mapping to tell me what the transformations were rather than sort of think it through. If I think it through, almost guaranteed to get that wrong.